Hello everyone, in this video we're going to talk about simulating outcomes. So what is a simulation and how can we use it to find the probability of something happening? Well, a simulation is just an experiment that is designed to reproduce the conditions of a situation or a process. So it's something where we want to conduct an experiment where the experiment is feasible for us to do, and it's going to give us insight into something that would be non-feasible to do, right? So we're going to take an example here where we have equally likely outcomes of our events, and then we have not equally likely outcomes of our events. And we're going to see the difference between the two. So let's look at our first example. It says a cat has 3 kittens. The gender of each kitten is equally likely. Design a 20-trial simulation to model the genders of the kittens, and then we're going to find the experimental probability that all 3 kittens are females. So a simulation that we could use would be flipping a coin. So on a coin we have heads and we have tails. Let's let heads represent the gender of male, and let's let tails represent the gender of female. So I'm going to bring up on the screen right now just a flip of the coin on the internet so that we can do this without me having to flip a coin multiple times. So what we're going to do here is we're having 3 kittens. Okay, so if you notice I have a 20-box table here, and we're going to flip the coin 3 times, and we're going to record the gender in each box. So for example, the box is going to say like heads, 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 or tails, 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 so on and so forth. Okay, and for number 1, it says find the experimental probability that all 3 kittens are females. So we're looking for only those favorable outcomes would be tails, tails, tails. Okay, so I'm going to flip the coin 3 times, and then I'm going to record what we have on the chart. Okay, so here we go. First one, we got tails, heads, tails. So tails, heads, tails. Let's do it again. Tails, tails, heads. Tails, tails, heads. Okay, tails, tails, heads. Tails, tails, heads. Okay, next 3. Heads, 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 heads. Okay, tails, 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 tails. Okay, so there's 1. Tails, heads, tails, tails, heads, tails. Heads, tails, tails. Heads, tails, tails. Tails, 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 tails. Tails, tails, tails. Wow, that's 6 in a row. Actually 7. Okay, heads, heads, heads. Heads, heads, heads. Heads, heads, tails. Tails, tails, heads. Tails, tails, heads. All right, we got about 8 more. Tails, tails, tails. There's another one. Tails, tails, tails. Heads, heads, tails. Heads, heads, heads. Okay, 5 more. Heads, heads, tails. Heads, heads, tails. Same as the last one. Tails, heads, tails. Tails, heads, tails. 2 more. Tails, tails, heads. Last one. Heads, heads, and heads. Heads, heads, heads. Okay, so now what we want to do is we want to go and look at those options or those outcomes where we had all 3 females. So that's tails, tails, tails. So we had 1 here. Tails, 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 another one here, and another one here. Okay, I think that's it. Yes, okay. So how many did we have? We had 4, we did it out of 20, right? So 4 out of 20, that's 1/5, which is about 20%. 20%, okay? So 20% would be our experimental probability that this cat, this female kitten, is having 3 female kittens, okay? So now, if we did this, obviously if we kept doing this, it's probably not gonna be exactly 4 out of 20 every single time, but it should be somewhere in the ballpark of 20%, okay? It's experiment, we're estimating, that's how we could use a simulation, okay? All right, now let's talk about not equally likely outcomes, okay? So now for this, it says we have a 70% chance to win game 1, and we have a 30% chance to win game 2. We're gonna design a 50 trial simulation involving randomly generated numbers to estimate the probability of winning both games. Okay, so now, did you know on your TI-84 Plus CE graphing calculator, you can actually randomly generate any set of numbers that you want. So we're gonna use that in this video, so let me bring that up, okay? So I've got my calculator here, and I'm gonna show us how to randomly generate 50 numbers in just a second, but let's talk about how we're gonna do that. So let's let game 1 represent the tens place in our numbers, and game 2 represent the ones place, okay? So if we have a 70% chance, let's let these numbers be 1 through 7, right? So those are good. Any 10s, 20s, 30s, 40s, 50s, 60s, 70s, those are good. Ones place, we have a 30% chance. So let's only consider numbers that are 1 through 3, okay? So we only want numbers, they're gonna be two-digit numbers. We only want numbers that have a tens value that's between 1 and 7, and a ones value that's between 1 and 3. Okay, so now let's look at the calculator, and I'm going to show you how we can use it to randomly generate some numbers. So if we click on this math button right here, and we're going to go over to where it says prob, which stands for probability. Let's go down to number 5 where it says rand int. So that stands for random integers. So let's hit enter there. Now our lower number we want to be 0, and our upper number we're going to do 99, and we want 50 numbers. That's what n stands for, okay? So we want numbers between 0 and 99, and we want 50 randomly generated numbers between that range. Let's go down here to paste, we hit enter, and now we're gonna hit enter again. Okay, so now it starts giving us some numbers. I'm gonna fill them out in this table. I'll try and go as quick as I can. And once we get to the end of our list, we can just arrow over like this, and it will show us our next numbers, okay? So we have 11, 24, 85, 24, 85, 37, 59, 60, 37, 59, 60, 7, 1, and 1. Okay, so now let's go over, and let's get past these two ones here. Okay, so we have 69, 70, 88, 69, 70, 88, 37, 11, 45, 98, 69, and now let's arrow over. All right, let's see. Looks like we have 54, 63, 92, 54, 63, 92, 67, 79, 55, 33, 21. All right, let's arrow over, get past that 21. Okay, so now we have 62, 88, 12, 62, 88, 12, 45, 46, 28, 45, 46, 28, 81, and 98. All right, let's arrow over, get past 98 there. Okay, 49, 40, 22, 49, 40, 22, 62, 61, 80, 77, 46. Okay, last 9 here. Okay, 92, 62, 92, 62, 33, 45, 80, 33, 45, 80, 86, 25, 86, 25, 71, and 46. Okay, so that's how we can use the calculator to randomly generate numbers. So now, let's look at our table here. Now let's go to white, let's switch up our color, and let's look for the numbers that have a tens value between 1 and 7, and a ones value between 1 and 3. Okay, so let's look at the first number, 11. Well, that's between 1 and 7, right, in our tens place, and also between 1 and 3 in our ones place, so that one's good. Okay, 24 is no good because the 4 is too large in the ones place. 5 is too large, 7 is too large, 9 is too large, 0 is too small. 7, 1, 1, those are only single digit numbers, so those aren't going to help us. 69, too large. 70, no, because we have the 0 in the ones place. 88, no. 7, 11 again is good. Okay, 45, nope. 98, 69, 54, 63, that would be good, right? Because 1 through 6, or 1 through 7, 6 would fit in there, and then 1 through 3. 92 is too large. 67, 79, 55, 33 is good. 21 is good. 62 is good. 88 is too large. 12 is good. 45, 46, 28, 81, nope. 98, 49, 40, 22 would be good. Another 62 is good. A 61 is good. 80, no. 77, 46, 92, 62. I think we had another 62. That's good. 33 would be good. 45, no. 80, 86, 25, 71 would be good. And 46, no. Okay, so we had 50 total numbers, right? Let's see how many we counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we got about 13 out of 50, which would be about 26 over 100, which should be about 26%, right? So what is our chance to win both of these games? We got about a 26% chance, okay? So I know that was a lot. Thanks for sticking with me in this video. We talked about simulating outcomes and how we could simulate those that are equally likely by doing a coin flip, which, you know, obviously we did on the computer, so I don't know the IT behind that coin flip. I don't know if it's actually 50-50, but for the purpose of this video, that's what we used, and it gave us a pretty legitimate outcome for our probability. And then for a non-equally likely outcome, we learned how to use the TI-84 Plus CE graphing calculator, how to randomly generate numbers on the calculator. And then we were able to figure out our experimental probability for a non-equally likely outcome event.